Hi friends, today we're going to be talking about our exponents quiz part 2, and we're going to start with number 1. It says simplify the expression. I have negative 2.6 to the fourth times negative 2.6 to the negative fourth. Remember that when I'm multiplying like bases, and these two bases are indeed the same, I add the exponents. I know that negative 4 plus 4 is 0, so that gives me negative 2.6 to the power of 0. I know that anything to the power of 0 is equal to 1. So my answer to number 1 should be 1. Number 2, again, I'm multiplying like bases. My bases are both 2's, which means I'm going to add the exponents. So this is going to be 2 to the negative fifth plus 2. I know that negative 5 plus 2 gives me negative 3. So now I have 2 to the negative 3. Now I can't have a negative exponent. So in order to make this negative 3 into a positive exponent, I need to take the 2 to the negative 3 and I need to bring it to the denominator. So now I'm going to have a 1 in my numerator, 1 over 2 to the positive 3. I know that 2 cubed is 8, so my final answer is going to be 1 over 8. Moving down to number 3. I start with taking 3 cubed to the squared, or a power to a power. When I take a power to a power, that means I multiply. 3 times 2 is 6. So this gives me 3 to the sixth over 3 squared. When I divide like bases, I subtract the exponents. So this is the same as saying 3 to the sixth minus 2. And that gives me 3 to the fourth. So when I evaluate 3 to the fourth, that's going to be 3 times 3 times 3 times 3. 3 times 3 I know is 9. I'm going to bring down my third 3. 9 times 3 is 27. And then I bring down my last 3. And I know that 27 times 3 is 81. So my answer to number 3 is 81. Looking at number 4, I start with a fraction. At the top of my fraction, I am multiplying like bases. Remember, when I multiply like bases, I add the exponents. So this is going to be the same as 5 to the 3 plus 2 over 5 to the 8th. 3 plus 2 is 5, so this is going to be 5 to the 5th over 5 to the 8th. Oops, that looks like 58, my bad. 5 to the 8th. Remember that when I divide like bases, and these are both the same base, I subtract the exponents. So this is the same as saying 5 to the 5th minus 8, which gives me 5 to the negative 3. Now I can't have a negative exponent because this 8 is bigger and it's on the bottom. I'm going to keep my 3 in the denominator. So I'm going to have 1 over 5 to the third. Now I'm not done quite yet because I need to fully evaluate this. So I know that 5 to the third is the same as 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. So my final answer is going to be 1 over 125. In this next section here, it says an equation is shown below. What is the value of n? And we did similar ones like this in our previous quiz. I need to figure out what number I can plug in for n to make this 1 to the 5th. Well, I know that in order for this 5 to go in the denominator, it would have to have a negative exponent. And in this case, my negative exponent would be 5 to the negative 1. Because if I have 5 to the negative 1, that would mean I needed 1 in my numerator, and I'd bring the 5 to the denominator. So my answer for number 5 is going to be n equals negative 1. Looking at number 6, I have 8 to the n equals 1. This one's pretty easy. I know that any number to the 0 power is 1. So I know that my n here has to be 0. Looking at number 7, it says evaluate the expression below. So 5 to the fourth, I'm going to keep. I'm not going to mess with that for right now. I'm taking a power to a power here. Negative 3 times positive 2 is negative 6. So this is going to be 5 to the negative 6. Remember, when I multiply, or when I take a power to a power, I multiply those numbers together. So now, when I'm multiplying like bases, that means I add the exponent. So this is the same as saying 5 to the fourth plus a negative 6. That's going to give me 5 to the negative 2, because negative 6 plus 4 is negative 2. Remember, I can't have a negative 2 or negative exponents in my problem. So I'm going to go ahead and I'm going to put 5 squared to make that exponent positive in the denominator, and I'm going to put a 1 on top. Now to fully evaluate this, I need to multiply out 5 squared, which is 5 times 5, and that gives me 1 over 25 for my final answer for number 7. And then last but not least, it says without using a calculator, convert 18 over 48 to a percent. Well, the first thing I need to do is get this to a decimal before I can change it to a percent. And so I'm going to go ahead and do long division. So I'm going to put my bottom number of my fraction on the outside of my division box. So I have 48 into 18. I know 48 can't go into 18, so I'm going to add a decimal and I'm going to bring down a 0. I know that 48 can go into 183 times. And I know that 3 times 48 is 144. So then I'm going to subtract. 180 minus 144 is 36. 48 can't go into 36, so I'm going to add another 0. I know that 48 can go into 360 7 times. And I know that 7 times 48, if I do long division, or sorry, not long division, if I do multiplication over here, 7 times 48, 8 times 7 is 56. 5, bring over the 5 here. 7 times 4 is 28. And 28 plus 5 is 33. So that gives me 336. Now I'm going to go ahead and subtract 360 minus 336. That's going to give me 24. I know 48 can't go into 24, so I'm going to add one more 0. 48 goes into 240 an even amount of times. 5 exactly. 5 times 48 is 240. I'm left with 0. So my decimal is going to be 0.375. Now, if I need to convert that to a percent, because that's what it's asking for, to get from a decimal to a percent, I need to move my decimal place 2 places to the right. So as a percent, this would be 37.5%. Good job, friends.